Hello everyone. On this video, I'm going to tell you more about Chapter 7 related concepts, and my plan is to work on 5 questions with you. So these questions can be found on Canvas, so I handpicked them to represent some of the key topics that you saw in Chapter 7. So in the first 2 questions, those are related to break-even point analysis. What I will do is I will first read the questions with you, and I'm going to introduce the basic notion and the basic notation when we use to tackle break-even problems. So let's get started. So question number 1, we do have a beauty salon, and here the owner's fixed cost is given us as 17,500 per month. So let's assume that those are pretty much fixed costs, like rental or equipment purchasing or some other fixed cost related expenses. And then there's also another information here. It says that the average variable cost for the beauty supplies she sells is $4 per unit. So this is a varying cost depending on the number of person that is arriving into this shop in that specific month, and says that the average selling price of a product that the salon sells is $9 per unit. By the way, these variable costs and variable returns are based on per product. And the question is, what is the break-even sales volume? So at what point, how many products this beauty salon should sell so that the company or company is at the break-even point? So what is break-even point? Let me um, represent that over a graph. Let's assume that on the y-axis we do have the dollar volume. Here we do have on the x-axis we do have the number of products. Okay, let's assume that this is what we are trying to represent, and I will call this as x. Okay, x would be our number of products. We do not know how many products we are going to sell this month, so let me try to represent my cost. Okay, I'm going to use red line to represent my cost. My cost starts at 17,500 because that's my fixed cost, and it increases at a rate of $4 per unit. Okay, and on the other hand, I do not have any fixed revenue. Therefore, let me use a different color for my revenue graph. I do not have any fixed revenue. Instead, every product that I sell is going to return me $9 revenue for each one that I sell. Well, as you can see, this graph is the revenue, all right? And this red line here, right here, right line is going to show me my cost. The break even is happening right at the intersection of the revenue and the cost functions. All right, so to the left of this graph, you see that our cost is higher than our revenue, therefore we are losing some money, right? Let's assume that this is our X, the number of products that we sell. To the right of this point, you see that our revenue is higher than our cost. It means that we are making profit. So we definitely would like to be on the right side of this break-even point. That's why companies would like to know their break-even point, so they work hard and hard and hard until they get to that point and hopefully stay to the right of that point. Okay, how do we know we are at the break-even? So that is, a very straightforward question to answer after this point, because we already said that the break-even happens to be at the intersection of revenue and cost. So why don't we just say revenue equals to cost, right? And we can represent our revenue. Our X would be, in this case, the number of products sold, in this month, right? Then we can definitely represent our revenue. Our revenue is 9 times X, right? And our cost would be once the fixed cost plus our variable cost or times X. And if you rearrange terms and leave X alone, 5X is equal to 17,500, and your X would be 3,500. All right. So if we sell any number of products that's higher than 3,500, the company is expected to make profits, right? If the company is selling less than 3,500 products, then company is definitely losing money. All right. This is the second question related to break-even point analysis. Let's first of all read the question together. Ranbaxy Pharmaceuticals Company is currently manufacturing a drug that has a variable cost and selling price of $1.20 per unit and $2 respectively. So their variable cost is $1.20 and their selling price is $2. Okay. The current fixed cost, they have a fixed cost of 25,000 and the sales volume is 25,000 units. And the company is considering adding new equipment to the production that can improve the production efficiency of this drug. Therefore, the new equipment will add an additional $9,000 to the fixed cost, and the variable cost per unit would decrease to $1. Right? Remember, if it was $1.20, and now they are projecting this number to go down to $1. It says, at what sales volume would adding this new equipment be profitable? Okay. This is the same, again, break-even analysis question, but we are given many different numbers here. All we need to think is, what is my revenue? As we know that at the break-even point, this is going to be equal to our cost, right? So let's think in terms of our fixed cost, variable cost, and our selling price. Well, the selling price, SP, is not going to change, right? It's going to stay as $2, all right? And our variable cost, on the other hand, is going to be going down to $1 after we make this improvement. What's going to happen to our fixed cost? Our fixed cost is going to be increased by $9,000, right? So therefore, we can represent our new fixed cost as $34,000. Okay. All right, so we do have the information to calculate our revenue and cost, and let's define X as number of units sold. Okay, we don't know X right now. X is the number of units sold at the break-even. And the revenue to calculate this is 2 times X, and our fixed cost is $34,000 plus $1 times X, right? And if we rearrange the terms, what happens here is X is going to be equal to 34,000 units. To be at the break-even, the company should sell 34,000 units. Okay.